Ever wondered why planes avoid the vast Pacific Ocean? It's not just about the distance. There's a fascinating mix of science, safety, and strategy behind it. Let's uncover the truth. Let's start with the myths. Oh, and there are plenty. Some whisper tales of a cursed ocean, plagued by unexplainable phenomena. Others claim it's an alien hotspot, with UFOs lurking beneath the waves, just waiting to snatch unsuspecting planes from the skies. And then there's the ever-dramatic belief that it's simply too risky or too big to cross. These ideas have been fueled by movies, urban legends, and the Pacific's own mysterious reputation, home to the Bermuda Triangle's notorious cousin, the so-called Dragon's Triangle. But how much truth lies in these whispers? Could the largest and deepest ocean on Earth really harbor secrets that scare away modern aviation? What if these legends held even a shred of truth? Could the vast, unpredictable Pacific Ocean be hiding dangers too great for technology to overcome? It's tempting to believe, isn't it? But as captivating as these stories are, the real reasons planes don't often fly over the Pacific aren't shrouded in mystery. They're grounded, quite literally, in the laws of physics, geography, and even the economics of air travel. So, stick with us as we dive deeper, pun intended, into the science, strategy, and surprising truths behind why your next flight is unlikely to take a scenic route over the Pacific. And hey, while you're here, hit that like button and share this video with someone who loves unraveling myths as much as you do. Now that we've set the stage with the myths, it's time to explore the real-world factors that keep those Pacific skies relatively quiet. Ready to take off? Let's go! When we think of flight paths, our minds often imagine a straight line stretching neatly across the map, connecting 2 points. But here's the catch. Our world isn't flat, no matter what conspiracy theories might suggest. This fundamental truth about the Earth's shape is one of the key reasons planes avoid the Pacific Ocean. What if the shortest path between two cities isn't actually a straight line? To understand this, let's talk about the Great Circle Route. On a flat map, it might seem logical to draw a straight line from, say, Los Angeles to Tokyo, right across the Pacific. But in reality, this approach is deceiving. Our planet is a sphere, and the shortest path between 2 points on a sphere isn't a straight line on a map. It's an arc. Imagine stretching a piece of string across a globe. Instead of cutting directly across the Pacific, you'll find that the string curves, often passing over land masses or regions closer to the Arctic. This is why flight paths rarely resemble the direct lines we see on flat maps. Pilots and aviation experts rely on the Great Circle Route, which is calculated to minimize distance and, by extension, fuel consumption and time. A great example? Flights between North America and Asia. Instead of flying over the vast empty Pacific, these routes often curve up and over, crossing the Arctic, or passing near Alaska and Russia. It's not only more efficient, but also safer, factors we'll delve into shortly. To visualize this, picture a globe versus a flat map. On a globe, the curve of the Earth reveals why these seemingly roundabout routes are actually the most direct. Flat maps, like the Mercator projection, distort distances and shapes, especially as you move closer to the poles. That's why what looks like a detour on a map is, in reality, the quickest way to travel. Now, imagine you're watching an animation of flight paths across the world. Planes zip over the Arctic and skim along continents, avoiding the endless expanse of the Pacific. Doesn't it make you wonder how many other misconceptions we've picked up from flat maps? The Earth's curvature is more than a fun fact. It's a critical factor in global travel, one that continues to shape the way we move across our planet. With that in mind, we're starting to see the bigger picture of why planes rarely cross the Pacific. But there's more to the story than geometry. Next, we'll explore the practical and safety considerations that further discourage these routes. Stay tuned. The Pacific Ocean is more than just a body of water. It's the largest and most daunting expanse on Earth, covering over 63 million square miles. To put that into perspective, it's larger than all the land masses of the world combined. Flying over this vast, seemingly endless stretch of ocean presents unique challenges that go far beyond the romantic idea of a great adventure. It's not just the size of the Pacific that makes it so intimidating. It's what's missing: infrastructure. Unlike flying over Europe or North America, where cities, airports, and emergency landing options dot the landscape, the Pacific offers very few such luxuries. The islands scattered across its expanse are tiny and often lack the infrastructure needed to accommodate large commercial planes. Imagine a scenario where a plane experiences mechanical failure or a medical emergency mid-flight. Over land, the pilot has options: divert to the nearest airport or make an emergency landing. Over the Pacific, those options shrink to nearly zero. Now, let's address the unthinkable. What happens if your plane experiences a critical failure and there's nowhere to land? While modern aircraft are marvels of engineering designed to handle multiple redundancies, emergencies do happen. History offers sobering examples of planes forced to ditch in remote areas. One such incident occurred in 1956 when Pan Am Flight 6, en route from Honolulu to San Francisco, had to make a controlled water landing in the middle of the Pacific due to engine failure. Remarkably, the passengers and crew were rescued by a nearby Coast Guard ship. But not every story ends as fortunately. Mechanical failure isn't the only concern. Weather over the Pacific can be incredibly unpredictable, with storms forming quickly and turbulence wreaking havoc on flights. Communication can also become patchy in remote regions, complicating navigation and rescue operations. Even with today's technology, crossing the Pacific comes with risks that pilots and airlines take seriously. And here's the human side of it. The thought of being stranded in the middle of the largest ocean on Earth, miles from civilization, is a fear that resonates deeply with passengers and crew alike. It's no wonder airlines often favor routes over land or areas with better infrastructure, even if it means flying a longer distance. So, while the Pacific may offer stunning views of endless blue, its vast, empty, and unforgiving nature makes it a less-than-ideal route for air travel. But these challenges aren't the whole story. There's another piece to the puzzle that involves economics and efficiency, and we'll uncover that next. Stay with us. High above the Earth, invisible rivers of air are constantly flowing, shaping the way planes travel across the globe. These are jet streams, fast-moving air currents that pilots use to their advantage whenever possible. They're like nature's aerial highways, offering efficiency, speed, and fuel savings. But here's the twist. Over land, jet streams are more predictable and useful, while over the vast Pacific Ocean, they can become obstacles. This is yet another reason why planes often avoid the Pacific. Jet streams are typically found at altitudes of 30,000 to 40,000 feet, the same cruising range for most commercial flights. Over land, pilots strategically ride these currents to save fuel and reduce flight time. But over the Pacific, where these streams are less consistent and sometimes accompanied by turbulence, they can complicate things. Strong headwinds or erratic turbulence can make a flight bumpier, longer, and far less fuel efficient. Weather patterns over the Pacific also play a huge role. Unlike land routes, where the geography helps stabilize conditions, the Pacific Ocean is a breeding ground for unpredictable storms, typhoons, and heavy turbulence. These conditions can force planes to take longer, circuitous routes, adding to the overall inefficiency of flying directly over the ocean. Fun fact, flying over the Pacific can be up to 15% less fuel efficient than sticking to routes that hug land or follow more stable jet streams. For airlines, this isn't just a matter of time. It's a matter of cost. And let's not forget the passenger experience. Turbulence over the Pacific isn't just uncomfortable. It can be severe. Imagine spending hours bouncing through rough skies simply because the route appeared shorter on a map. Would you want to endure that just for a direct path? Airlines know the answer for most travelers is a firm no, which is why they often prioritize smoother, more efficient routes over those that might seem faster. To visualize this, picture a plane traveling between North America and Asia. Instead of heading straight across the Pacific, it curves over Alaska or skirts the Arctic. By doing so, it taps into favorable jet streams while avoiding the unpredictability of open ocean weather. It's a win-win for both efficiency and comfort. So, while jet streams and weather patterns might not be the first things that come to mind when planning a flight, they're critical to understanding why planes often avoid the Pacific. But there's still more to this story. Next, we'll look at the financial and logistical factors that seal the deal for airlines when it comes to flight paths. Stick around. When it comes to flight routes, every decision airlines make boils down to one key factor: cost. Flying isn't just about getting from point A to point. First, let's talk about fuel consumption. Planes are designed to be most efficient when flying shorter distances and with favorable wind conditions. Crossing the Pacific directly is a fuel-intensive endeavor. The lack of consistent jet streams and the added weight of carrying extra fuel for such a long, isolated journey make these routes far less economical. In contrast, transpolar or North Pacific routes, like those that curve over Alaska, are shorter and make better use of natural wind patterns, significantly reducing fuel costs. Time is another major factor. Airlines don't just consider the distance between two cities. They calculate how long a flight will take. Direct Pacific crossings often encounter weather challenges like turbulence or headwinds, increasing flight time and putting additional strain on both the aircraft and the crew. Longer flights also mean higher costs for staffing and operational requirements, not to mention the inconvenience of extended travel for passengers. For example, flights from Asia to the United States rarely take a straight path across the Pacific. Instead, they use routes that hug the North Pacific or even cross the Arctic. These paths may appear longer on a flat map, but they're quicker and more cost-effective on a spherical Earth. Airlines optimize these routes to save millions of dollars annually, and passengers benefit from reduced ticket prices as a result. Now, let's put this into perspective. Imagine you're booking a flight and have two options. One ticket costs $500 for a comfortable, efficient route over land and polar regions. The other ticket costs $1,000 and takes you directly over the Pacific, with added turbulence and a longer travel time. Which would you choose? Most of us would gladly take the smoother, cheaper option, and airlines know this. It's not just about economics, though. Logistical concerns like emergency landing options, maintenance capabilities, and the availability of alternate airports also play a role. Airlines prioritize routes that minimize risk and maximize efficiency, making Pacific crossings a less attractive option unless absolutely necessary. So, while the Pacific may be vast and mysterious, it's also expensive and impractical for modern aviation. This combination of financial and logistical realities makes avoiding it a no-brainer for airlines. But now that we've explored all these factors, it's time to zoom out and wrap everything together. Stick around as we land this discussion with some final thoughts on why planes don't fly over the Pacific Ocean. For transcontinental flights, the polar route isn't just a shorter path. It's a safer and more practical alternative to flying over the Pacific. While the vast ocean offers little in terms of emergency options, the polar regions provide a lifeline for pilots and passengers alike. From stable weather conditions to strategically placed landing sites, polar routes are the preferred choice for crossing the globe. One of the biggest advantages of polar routes is proximity to emergency landing options. Imagine a flight encountering mechanical trouble mid-journey. Over the Pacific, options are sparse, with vast stretches of open water and a scattering of small islands, many without the infrastructure to support large aircraft. In contrast, polar routes pass near well-equipped locations like Alaska, Canada, and northern Russia. These regions are dotted with airports and airbases that can serve as critical safety nets in an emergency. And here's an impressive fact that underscores just how much thought goes into these routes. Modern aircraft are designed to fly over 2,000 miles on a single engine, if necessary. That's a testament to engineering. But it's also a relief knowing that polar routes offer reachable alternatives within that range. Pilots don't just rely on the aircraft's capabilities. They plan their routes with contingencies in mind, ensuring they're never too far from a safe landing. Weather conditions also play a significant role. While the Pacific is notorious for its storms, typhoons, and heavy turbulence, the polar regions tend to have more stable weather at cruising altitudes. This means fewer bumps for passengers and more predictability for pilots, which translates to smoother and safer flights. It's a stark contrast to the unpredictable and sometimes violent conditions over the Pacific Ocean. Now, let's visualize the difference. Imagine you're looking at a map of two flight paths, one crossing the Pacific, the other taking a polar route. On the Pacific path, the map is mostly blue, with just a few dots representing remote islands. Emergency landing options? Practically non-existent. Now, shift your eyes to the polar route. You'll see land, Alaska, Canada, Russia, and airports strategically placed along the way. The difference is clear. The polar route offers not just efficiency, but peace of mind. With all these factors in mind, it's no surprise that polar routes have become the go-to choice for transcontinental flights. They're shorter, safer, and logistically smarter, making them a win-win for airlines and passengers alike. But now that we've explored the myths, science, and practicalities behind flight paths, it's time to tie everything together. Let's land this journey with some final thoughts on why planes avoid the Pacific Ocean. While it's true that most planes avoid the Pacific Ocean, there are rare exceptions when flights do traverse this vast expanse directly. These exceptions reveal just how far aviation technology has come and hint at the future possibilities for global travel. Ultra-long-haul flights and specialized routes are rewriting the rules, challenging the traditional preference for polar or land-hugging paths. One prime example is Singapore Airlines' non-stop flight from Singapore to Los Angeles, a journey that spans over 8,700 miles and takes nearly 18 hours. This route crosses the Pacific directly, defying the typical aversion to such flights. How is this possible? Advanced aircraft like the Airbus A350 and Boeing 787 Dreamliner have been designed specifically for long-haul efficiency. They boast cutting-edge fuel technology, lighter materials, and engines optimized for endurance. These innovations make flights across the Pacific safer, more fuel-efficient, and economically viable. But even these flights are carefully planned with safety and logistics in mind. Non-stop Pacific crossings are typically flown by airlines with robust contingency strategies. These include meticulous fuel calculations, weather assessments, and predetermined emergency diversion points, often small islands with adequate landing facilities. For instance, some routes factor in remote locations like Hawaii or Midway Atoll as potential safety nets, ensuring that even in the rare event of a problem, there's a plan in place. These specialized flights also rely on technological advancements in navigation and communication. Modern planes are equipped with state-of-the-art systems that allow pilots to stay connected with air traffic control and monitor weather conditions in real time, even in the remotest parts of the Pacific. This wasn't always the case. Just a few decades ago, such routes would have been deemed too risky due to the limited technology of the time. Now, let's look to the future. Could advancements in aviation make Pacific crossings more common? With the rise of ultra-long-haul flights and breakthroughs in fuel technology, like the development of hydrogen-powered aircraft or improved battery systems for electric planes, it's not hard to imagine a world where the Pacific becomes less daunting. Airlines are already experimenting with even longer routes, pushing the boundaries of what's possible in air travel. So, while Pacific crossings are still rare exceptions today, they offer a glimpse into what's next for aviation. Would you be willing to spend 18 hours in the air for a seamless, non-stop journey across the Pacific? Let us know in the comments below. And now, let's wrap up this journey with some final reflections on why planes avoid the Pacific and what this tells us about the incredible world of aviation. As we stand on the cusp of new technological breakthroughs, the aviation industry is inching closer to making routine flights across the Pacific Ocean a possibility. From innovations in fuel efficiency to the advent of hypersonic and electric aircraft, the barriers that once made Pacific routes impractical are steadily falling away. One of the most exciting developments is in aircraft reliability and fuel technology. Next-generation planes are being designed to travel longer distances with greater efficiency, reducing the need for multiple fuel stops or concerns about emergency diversions. For example, hydrogen-powered aircraft and advanced battery systems for electric planes could dramatically increase range while cutting emissions. These innovations are paving the way for safer, greener, and more economical trans-Pacific flights. Then there's the rise of hypersonic travel, which could revolutionize how we cross the skies. Imagine flying from Los Angeles to Tokyo in just a few hours, cutting directly over the Pacific. These futuristic aircraft, capable of traveling at speeds over 5 times the speed of sound, would not only shorten travel times, but also eliminate many of the logistical challenges posed by long-haul routes. But even with these advancements, one question remains. Will passengers embrace this new era of Pacific travel? Comfort, safety, and cost will continue to be deciding factors, even as technology offers faster and more direct routes. Airlines will need to strike a balance between innovation and human needs, ensuring that the benefits of cutting-edge technology translate into better experiences for travelers.